I've been comparing these two mechanisms by saying things like tertiary alkyl halides proceed by SN1, or that methyl halides proceed by the SN2 mechanism. But in fact, you can choose solvents in a way that will predispose a mechanism to be one or the other, regardless of what the alkyl halide is. You can force reactions to proceed by SN1. It's just that under certain circumstances they're very slow as to be very inefficient. Same with SN2. You can choose solvents that speed up the rate at which an SN2 reaction occurs, or you can grind it to a halt, although you obviously wouldn't want to be doing that. Well, in the world of solvents, these two categories mentioned here are what are important for nucleophilic substitutions. You've got polar protic solvents and polar aprotic solvents. You need polar solvents because we're generally trying to dissolve not only an alkyl halide, which may have some polarity to it, but especially for the ionic salts like the sodium and potassium salts that provide our negative nucleophiles, the negatively charged nucleophiles. You need a solvent that's good at dissolving those. But within the world of polar solvents, again, we've got protic and aprotic, and one of them, as you can see, increases the rate of SN1 reactions, and the other is good for SN2. Protic solvents, protic comes from the word proton, but it's really referring to hydrogen. Hydrogen atoms just have the one proton in their nucleus, so that's the connection there. And if that hydrogen is directly connected to either oxygen or nitrogen, then we call the solvent protic. Water is the most famous example. Alcohols have all the OH groups in them. Amines feature nitrogen that is oftentimes connected directly to hydrogen and also to other carbons. They form a pretty big class of substances that are oftentimes good solvents. Aprotic oftentimes contains the same elements as a protic solvent, but the connectivities are what are going to matter here. And you can see I've listed a couple of examples here. Acetone you've probably heard about. That's the most famous of the polar aprotic solvents, and acetone here, if I line it up, there's the corresponding structure. Two methyl groups on either side of that carbon-oxygen double bond. That's a carbonyl group. We're going to talk a lot about carbonyl groups here before too much long. Dimethyl sulfoxide is a solvent that is good at dissolving nucleophiles, good at dissolving alkyl halides, but is again in this class of being aprotic. Got lots of hydrogens, but again they're all connected to carbons. So acetone and dimethyl sulfoxide are both similar in structure. We just have a sulfur taking the place of the carbon there, and you will oftentimes see dimethyl sulfoxide abbreviated as DMSO. Sometimes that's written below or above a reaction arrow to indicate that's the solvent. And it's also trying to indicate that it's a reaction that's going to proceed by SN2 because it encourages that mechanism so much. This last name here, dimethylformamide, that corresponds to this structure, and dimethylformamide is oftentimes just written as DMF. Another choice of solvent that again speeds up and encourages SN2. Down here in this bottom paragraph, it explains kind of the why of all of this. Protic solvents, like water alcohols, are very good at dissolving ionic compounds and dissolving alkyl halides. But the resulting nucleophiles, especially when they have that negative charge, they interact so strongly with the hydrogens in protic solvents that it kind of surrounds them and prevents them from behaving as a good nucleophile. It bogs them down, as it says here. Whereas aprotic solvents are still able to dissolve many of the same materials that protic solvents do, but they don't interact quite as strongly. So in an aprotic solvent, a nucleophile can be more naked, you might say, undressed, able to do its thing, which is substitute at carbon and form the kind of products we've been talking about here. So when these solvents like acetone and DMSO and DMF, when they were first used, it was found that they did quite a great job in speeding up the rates of the kind of reactions that again correspond to the SN2 mechanism.